Hello my dear students, welcome back to computer science classes. So in our previous video we had completed the functional components of computer. We had discussed in brief about the input unit, the central processing unit, under which we have also discussed about the memory unit, then ALU, that is arithmetic and logic unit, and control unit, and we have also studied about the storage unit and finally the output unit. So in this video, let us start with the evolution of computer. So before the computer system had come into existence, there were many computing devices that had come into existence. So therein, the first computing device that had come into existence for the counting purpose was the abacus. Okay, so when I discuss about the evolution of computers, here mainly we are concentrating on the device name, who has invented it, for what purpose they have invented. Apart from it, how it has been working, what is the logic they had used for the working of those computing devices, we are not studying that. We are only concentrating that who has invented that particular device, for what reason it was being devised. So mainly on these concepts we are concentrating. So let us start. The first computing device that had come into existence was the abacus. Okay, so abacus is known as the first known calculating machine which was being used for the counting. So this abacus is actually made up of the beads. These are the beads and the cords. So abacus is made up of the beads and the cords, where the beads are strung on the cords. That means the beads are being made to place on the cords, and they are being used to perform the simple arithmetic calculation, where these cords represents the position of decimal digits like units, tens, hundred, thousands and all, whereas the beads represents the digits. This abacus was mainly used to perform addition, subtraction, division and multiplication. Nowadays this abacus is also useful to calculate the complex calculation as of the modern computers. But this abacus was the first ever calculating machine that was being used for the counting purpose, which had come in the existence 2500 BC. Okay, so there will be one question for you, very important question. Name the first earliest computing machine. Name the earliest computing machine means the answer for this is abacus. Or they may also ask you to write the short note on abacus. Then you need to explain that abacus is the first known calculating machine used for the counting purpose, wherein it is made up of the beads and the cords, where cords actually represents what? The positional of decimal digits, whereas the beads actually, these are the beads, actually represents the digits. Okay, so abacus was mainly used to perform addition, subtraction, division and multiplication. So these points you need to write. Moving on to the next computing device, that is, so this is one of the another image of the abacus. So with this is entire this plate, it is called actually as the frame. These are the upper beads, these are the lower beads. You can see that these are representing the units, place and all. Fine, this is the rods, bar. So with the different, we are not actually concentrating on how exactly abacus was been working. We are concentrating on who has developed it, in which year it had come into existence and for what purpose. Moving on to the next one, that's the Napier's bones. Okay, so this Napier's bone was been actually invented by a mathematician, a Scottish mathematician known as the John Napier. It was mainly used to perform the multiplication. You look at here. So this Napier's bone included almost around 9 rods. Okay, one for each digit, that is 1 to 9. 1 to 9 means it will be 8 rods plus 1. We had a constant rod for 0. Okay, a rod was being actually, each one of the rod has been similar to one column of multiplication table. Okay, so that is how you can see here. This is 1 stable it is. Okay, constant is 0. Here if you see, it is a 2 stable. Okay, this is what is 3 table. This is 4 tables. Each one of the rod is actually representing one column of multiplication. So this Napier's bone actually, it had come into existence in the year 1614 AD, which was being developed by the Scottish mathematician. Mainly it was being invented to perform the multiplication, wherein it is making use of total 9 rods, one that is right from 1 to 9 plus a constant rod for the 0, wherein each rod is actually representing one column of multiplication. I hope it is very much clear to you all. So moving on to the next one, that is the slide rule. The slide rule is actually being invented by a person known as William. So this slide rule was being based upon the principle. So what was that principle is that the actual distance from the starting point of the rule is directly proportional to the logarithm of the numbers printed on the rule. Based upon this principle, the slide rule was working. I repeat the principle. It is that the actual starting distance, the actual starting point, distance of the starting point to the rule is directly proportional to the logarithmic of the numbers printed on the rule. So this slide rule was actually being combined by the 2 scales. You can see here, this is first half, this is one scale and this is one scale. Okay, so it has been embodied by the 2 sets of scale which are being joined together with the marginal space between them. So here to here is the one scale and here to here is the another scale. They are being joined together by this marginal space. Okay, so this slide rule was mainly developed in order to perform the multiplication and division by the method of addition and subtraction. For this purpose, the slide rule had come into existence in the year that is 1633 AD, which was being developed by the person known as the William Oughtred. I hope you are able to understand. Okay, moving on to the next one, that is the adding machine Pascaline. So these are the 3 points that you need to write for the slide rule. Okay, notes will be provided for you all. Moving on to the next one, that is the adding machine Pascaline. So this adding machine Pascaline, it was also called as the rotating wheel calculator. Okay, this adding machine Pascaline, it is also called as rotating wheel calculator, which was being developed by the French philosopher known as the Blaise Pascal. So this person was actually he was very much fascinated by his father's computational work, and he actually devised this model at the age of 19 itself. Okay, so hence it was being named as the Pascaline, that is adding machine Pascaline. Okay, then this machine, actually adding machine, has 8 movable wheels. You can see that 1, 2, 3, 4, 5, 6, 7, 8. It had 8 movable wheels known as the dials. Through these dials, they were able to enter the numbers. Can you see here? There are the numbers. Through these dials, they were able to enter the numbers, and this device was able to perform the addition and the subtraction and division as well as the multiplication. So it was able to perform addition, subtraction, division and multiplication as big as the 1000. So this machine actually laid the foundations for the today's modern electronic calculators. Okay, so because of it was able to perform calculations as big as thousands in numbers, it laid the foundation that whatever the today's electronic calculator we are having. Okay, so this was all about the adding machine known as the Pascaline, which had come into existence in the year 1642, which was being invented by the French philosopher known as the Blaise Pascal. It had 8 movable wheels known as the dials. Through these dials, we were able to enter the numbers, and this device was able to perform what? Addition, subtraction, division and the multiplication as in terms of thousands. Okay. Moving on to the next one, that is Leibniz calculator. Okay, so this is how the adding machine looks. Yes, Leibniz calculator was actually come into existence in the year 1650, which was being invented by the mathematician known as Gottfried Leibniz. okay, which was able to perform addition, subtraction, division and multiplication. Okay, so herein we don't have much explanation about the Leibniz calculator. We should only write that Leibniz calculator was been invented by the mathematician known as the Gottfried Leibniz, which was capable of performing addition, division and subtraction and multiplication. But one question you have, that is, what are the advantages of Leibniz calculator over the Pascaline? Okay, in that case what you should write is, actually initially when Pascaline was being invented, it could only perform addition and subtraction. Okay, it was not able to perform multiplication and division. But after that, actually Leibniz calculator had come into existence, wherein it was able to perform addition, subtraction, division as well as multiplication. As the days went on, upgradation took place in the Pascaline machine. Later on, it was able to perform even the division and multiplication. So when they ask you the question like what are the advantages of Leibniz calculator over the Pascaline, you should write as Leibniz calculator was able to perform addition, subtraction, division and multiplication, whereas the Pascaline was able to perform only addition and subtraction at the initially. You have to mention this clearly. Okay, finally after once it was upgraded, it was able to Pascaline was able to completely perform the addition, subtraction, division and multiplication. That's how you need to write the answer for that particular question. I hope you are able to understand. So moving on to the next machine, next computing machine, that is Jacquard's loom. So this is again another slide of internal view of this Leibniz calculator. Okay, moving on to the next one, that is the Jacquard's loom. Okay, so in the year of 1801, okay, there was a person known as Joseph Mary Jacquard. He actually invented a powered loom. This is nothing but the powered loom, which was using the punched cards. These are the punched wooden cards, which was able to incredibly weave the patterns, including the pictures and the text. So these are the wooden cards onto which this machine, powered loom, was able to weave. We were able to get the patterns of text and the images. Before that, we didn't had any hard disk, hard copy of the devices. You can see we had Leibniz calculator, we had Pascaline, we had slide rule. It was not generating any of the output. We were unable to weave it, right? We were unable to see it. Whatever the answer, we were able to get it in the device itself. But here, this was able to print. It was able to weave on the punched wooden cards, that is the pictures and the text as well. Hence we consider this as to be the first read-only memory device. Okay, they'll be asking question, which one you are able to consider the first read-only memory device? That means you should be able to write that it's a Jacquard's loom is considered to be the first read-only memory device. And this Jacquard loom is also called as powered loom calculator. You can call it as powered loom calculator. So he was a person, Joseph Mary Jacquard, who actually invented this powered loom calculator. I hope you are able to clearly understand with these images. Okay, moving on to the next computing device, that is the difference engine by Charles Babbage. So the difference engine had come into existence in the year 1822. So as we know that Charles Babbage is being called as the father of computers, isn't it? Why he's being called as father of computers? Let us see. Okay, so Charles Babbage, he was a British engineer and a mathematician who was actually developed an automatic calculating machine known as the difference engine. This is the automatic calculation machine. Okay, this is nothing but the difference engine, and later he thought of mechanical construction of this difference engine and called that machine to be as the analytical engine. Okay, so when this analytical machine, it was actually called as mechanical digital computer. This analytical engine is also called as mechanical digital computer. So this analytical engine consists of 5 units. Okay, 5 units, that is input unit, output unit, okay, memory unit, processing unit and the storage unit. So it includes the 5 basic units that laid the foundation for the today's modern computer. That is why the Charles Babbage has been considered as the father of computers. I hope you are able to understand. Initially, Charles Babbage had developed a automatic calculating machine known as difference engine. So this difference engine was able to perform the differential equations. It was able to perform the calculations of differential equations. Later, he thought of mechanical construction of this, of this difference engine. So when he actually laid the foundation, and he called that mechanical construction as a mechanical digital computer known as analytical engine. This analytical engine had consisted of 5 units that laid the basic principles for the modern computer system. That's why he is being called actually as the father of computer. But you know that analytical engine was never completed at the time of Charles Babbage. He just laid the foundation for the analytical engine, but he couldn't complete the work what he has been started. He couldn't even start, but he had written all the notes and all what the analytical engine and how it should be constructed. In that, when the others actually tried to implement that, try to construct this analytical engine, they could able to see that it consisted of 5 units. Then that 5 units, by using those units, our modern computers are working today. Therefore, they are being considering the Charles Babbage to be as the father of computers. He was able to complete only the differential engine, but he never started the work of analytical engine. Instead, he had written every notes to have the mechanical constructions of it. Moving on to the next one, that is the first programmer known as the Lady Ada Lovelace. So she's been called as the world's first programmer known as the Lady Ada Lovelace. So she was a great mathematician. She was a mathematical genius. She was actually working with the Charles Babbage on the analytical engine. She was, when analytical engine Charles Babbage thought of, then Lady Ada Lovelace, she was working with the Charles Babbage and she started writing the computer notes for it. And she wrote the first ever computer algorithm. That is why she's been named as the world's first programmer. Then she was the lady who actually predicted that the later computers have the ability to do more than mathematical calculations. She realized that the analytical engine what has been getting which may be developed can manipulate the symbols and music notation. She predicted that the computers are capable of doing more than the mathematical calculations. In those days only she was able to predict, and she called herself as an analyst and the metaphysician. So the analyst is the one who is doing the research, who is having the deep knowledge of that particular machine or something. They will call them as analyst. Metaphysician in the sense the one who is in master in terms of philosophy. She was actually having the masters in philosophy, and she was a great mathematician genius also. So she wrote the first computer algorithm, and she is being considered to be as the world's first programmer. So you will be getting an important question, names the world's first programmer, then you should write the complete answer as Lady Ada Lovelace. Even in the Charles Babbage also, Charles Babbage, write a short note on Charles Babbage. It is a very frequently asked question, and they will also ask you who is considered to be as the father of computer. Then you have to say about the Charles Babbage. So students, so we have seen the evolution of computers. So one more device has been left out, that is the Hollerith tabulating machine, which we will be completing in our next video. Thank you students.